Okay, here is the mock exam for the extension section of polynomial functions. First problem is find all rational roots of this function. So this combines a lot of the skills that you've learned along the way. And remember the rational root theorem. That's the thing that's going to get you started, because you know how to verify numbers that are roots of a polynomial function. You use synthetic division. But how do you know what numbers you are going to try out? Those numbers you can find by the rational root theorem. And so in this case, as you know from your watching the video on rational root theorem, there's a few possible rational roots, which are plus 2, minus 2, plus 1, minus 1, plus 1/2, and minus 1/2. Okay? And if you don't know how I got those, please watch the video. I am going to try first positive 1, because positive 1 is one of the easiest numbers to do synthetic division with. So I'm going to set this up, and look, I'm going to check, first of all, do I have consecutive degrees? 4, 3, 2, 1, constant. So we're missing the second degree. So when we do the synthetic division, we just need to be careful to leave a space for it, okay? So I'm going to put my degrees here. My first degree is actually 4th degree, 3rd degree, 2nd degree, 1st degree, and 0. And so I'm going to put the coefficients, which are 2, 6, negative 6. Oops, I forgot 2 is, I need to skip that. It's really easy to make a mistake. Okay. And now I'm going to do the synthetic division. So I have 1 here, and so I'm going to bring down the 2, multiply it by 1, add those, multiply by 1, add those, multiply by 1, add those, multiply by 1. And what a relief! On the very first try, without trying any of the rational roots, we find out that one of the rational roots is 1. And not only do we know that the rational root is indeed 1, we also know that the polynomial that's left over after you divide by the binomial x minus 1, you get this leftover polynomial, right? Because, okay, this is what you're left over. This is what you have left over. So right now we have this. We have x minus 1, because that's what we divided out, right? This represents x minus 1. And that is multiplied times 2x cubed plus 8x squared plus 8x plus 2. Okay? So now what we need to do is we need to figure out what are the roots of this one. So we're going to try the roots for the possible roots for this one. And again, we have 2, negative 2, 1, negative 1, 1/2, and negative 1/2. We have the exact same ones. Well, remember, 1's the easiest one to do most of the time, so we're going to try one more time our luck, see if we can do a synthetic division with 1 and have it come out perfect again. There are no skipped degrees here. It's 3, 2, 1, 0, so we don't need to leave any zeros in our coefficients here. Bring down the 2, multiply by 1, add, multiply by 1, add, multiply by 1, and didn't work out, did it? Okay, we ended up with a non-zero remainder, so that was a fail. Now we're going to try another one. Another one that's easy to try is negative 1, so let's do negative 1. So we're going to have 2, 8, 8, 2, bring down the 2, multiply by negative 1, add, multiply by negative 1, add, multiply by negative 1. Hey, it worked out. Okay, this time we got remainder 0. So that means one of the other roots is negative 1, which means if we wanted to rewrite it, we would now have x minus 1, which we got before. Then we got x plus 1, which we figured out now. And then we're going to write down this remaining polynomial, which is 2x squared plus 6x plus 2. Okay, and now we just need to figure out what are the roots of this quadratic. We're almost done. Remember, to find the roots of the quadratic, you can just use quadratic formula. So we're going to do x equals negative b, which is negative 6, plus or minus the square root b squared, which is 6 squared, minus 4ac, which is 4 times 2 times 2, which is 16, divided by 2 times a, which is 2 times 2. And so this simplifies into negative 1.5 plus or minus square root of 20 divided by 4. And this can be simplified into, I could break up 20 into 4 times 5. Square root of 4 is 2 times square root of 5. And then I could cancel these. I end up with negative 1.5 plus or minus square root of 5 divided by 2. Now I have figured out the two roots of this part of the polynomial. It's going to be negative 1.5 plus square root of 5 over 2 and negative 1.5 minus square root of 5 over 2. And of course I still have the roots negative 1 and positive 1, which I discovered before. So it has 4 roots, which makes sense because it was a 4th degree polynomial, and 2 of them are rational, and 2 of them are irrational. And what it asked me for is find all the rational roots. So actually, I didn't really need to find these because it didn't ask me for the irrational roots, and those are 2 irrational roots, right? Because it's got square root of 5 and it's irrational. So we only needed to find these 2, okay? So if you were clever, you could already see from the discriminant that you were not going to get a perfect square. So you already knew that this was doomed to find irrational roots. You could have stopped that. I was not clever, so I went too far. Okay. Write a polynomial of least degree with real coefficients and with roots negative 1 plus 2i and negative 2 plus i. Okay, so the way you would think about this one is, well, if you have a imaginary or complex imaginary root, you know that you have conjugate pairs as roots, right? So if you know that that's one of the roots, then the other root is going to be the conjugate pair. If you know you have this one, the other root is going to be a conjugate pair. So now we have 4 roots, okay? So if we have 4 roots, we can write out our polynomial like this. Negative 1 plus 2i, x minus 1 minus 2i, and x minus negative 2i plus negative 2 plus I, and finally x minus a negative 2 minus I. And you can see all I did here was I basically just filled in each one of the roots into the right side of x minus something, x minus something, x minus something, right? Okay. Now I just need to multiply it out because it just says to find the answer in standard form, which means it's going to be a polynomial with descending x degrees of x exponents. So first thing I'm going to do is going to multiply these two together. And remember that when you multiply together conjugate pairs, you can get rid of the imaginary parts of the complex numbers, okay? So I'm going to do FOIL. Here I'm going to get x squared, right? If I do this and this, and I multiply those two together, add them together, then the conjugate pair, the imaginary parts cancel each other out, and what's left is only the Oh, I made a mistake here. You see, there should be a negative there, right? Right, okay. So the conjugate pair parts cancel each other out, and the real parts remain. So the negative 1 x is going to remain for each part, so it's going to be negative 1x, and actually it's positive 1x, right? Because I'm going to multiply together positive 1 times x times positive 1 times x, and so that's how I get that. And then finally, I'm going to multiply together these last two. I'm going to multiply the two last terms. And when I multiply together conjugate pairs, it's like I do a mini FOIL. And so I'm going to get negative 1's quantity squared, and then the middle term is going to be canceled out, right? And then the last term is going to be positive 2i multiplied times negative 2i, so that's going to give me negative 2i squared, right? And if I was to simplify or to combine the like terms here, I would get x squared plus 2x plus 1, and then 2i squared would be negative 2, or negative 4, right? Because I squared is negative 1. Multiply that times 2 squared, which is 4. You get negative 4. So it's minus a negative 4, which would be positive 4. Okay? And so now I can combine that into plus 5. Right? Now I'm going to do the same thing with here. Okay? So I'm going to do FOIL again. So I'm going to get x squared. And then for my middle term, remember that the complex parts, the imaginary parts cancel out, and I'm left with the non-imaginary parts, which would be plus 2i, which would be plus 2x plus 2x, which would be plus 4x, and then last of all, I'm going to combine these two. So it's going to be I'm going to do like a mini FOIL again. So it's going to be like negative 2 squared, and then I'm going to subtract the last term squared. Okay. Okay. Now I'm going to simplify this, and I'm going to get x squared plus 4x plus 4 minus a negative I, which is plus 1. And so I end up with x squared plus 2x plus 5 times x squared plus 4x plus 5. Okay? And now I'm going to do another multiplication. I'm going to multiply this times this. I'm going to do it with lattice multiplication, okay? Because I think less chance for error. So basically, I'm going to write each one of the polynomials alongside a table or a lattice. And then in each box, I'm going to write down the multiplications. So I get 2x cubed here, we get 5x squared here, 4x cubed here, 8x squared here, 20x here, 5x squared here, 10x here, 25 here. And then I do a lattice addition for each one. And so I'm going to get 25 here and 30x here. And then I'm going to get a 18x squared here. And then here I'm going to get a 6x cubed, and then x to the 4th. Okay? So if I wanted to write it out all in a line, I would just say x to the 4th plus 6x cubed plus 18x squared plus 30x plus 25. Okay? And I just checked my answer with what I got before, and it's fine. Okay, so now I'm going to do the last part, which is to write out Pascal's triangle to row 6 and expand and simplify 2x plus 3y to the 6th power. So remember Pascal's triangle. You should be pretty good at it now. Okay, and the number 6, the n equals 6 row looks like that, right? So we're going to use those coefficients to, I'm just going to put this down here for now. Okay, so we're going to use the coefficients. It's going to be 1, 6, 15, 20, 15, 6, and 1. And then we're going to put these values in as the second and third multipliers for each term. So, for example, we're going to put 2x quantity to the 6th, 2x quantity to the 5th, 2x quantity to the 4th, 2x quantity to the 3rd, 2x quantity squared, and 2x. And then the 3y, I'm going to just write it in a different color. 3y to the, it's 3y to the 0, so there's no 3y term here. This is the first 3y term. 3y to the 1st, 3y to the 2nd, 3y to the 3rd, 3y to the 4th, and 3y to the 5th, and 3y to the 6th. And I am going to put addition signs in between each term because all these terms are added together. Okay, now I need to simplify. 2 to the 6th is 64. So 64x to the 6th. Here I have 6 times 2 to the 5th, which is 32, times 3. That's 18 times 32. Get out your calculator. 18 times 32 is 576. X to the 5th, y, And then the next one is going to be 15 times 2 to the 4th. 2 to the 4th is actually 16. 3 squared is 9. I'm going to multiply those together. 15 times 16 times 9. 2160 x to the 4th y squared. Next one. 20 times 2 cubed, which is 8, times 3 cubed, which is 27. Let me do those. 160 times 27, 4320 x cubed, y cubed. Okay, next one. 15 times 2 squared, which is 4, 3 to the 4th, which is 81. 15 times 4 times 81. 4860. X squared, y to the 4th. Okay. And this term here, it's going to be 6 times 2 times 3 to the 5th. 3 to the 5th is 243. So 243 times 2 times 6 is 2916. X, y to the 5th. Finally, plus 3 cubed, which is 243 times 3, 729 y to the 6th. Okay? And that's it.